We are back again. Today we are going to look at the introduction to differentiation of inverse trigonometry. But before we get to taking the differential of inverse trigs and all that, I want us to introduce ourselves to some basic things that we need before we can get there. I always clear. Alright, so now, for a function to have an inverse, it has to be what? One-to-one what? Function. That means that if you have a function and it's not one-to-one function, it will not have a what? Inverse. When we say a function is a one-to-one function, what do we mean? You know one-to-one. That is, for instance, if you do a substitution of, let's say, 2 inside of a function f of s, then you get your results. It will not be a case, or there will not be a case that when you do a substitution of, let's say, x to be equal to -1 into a function, then you get 2 results for 1. It will not be that. But if you do a substitution into a function, you get only 1 result like that. That is what? One-to-one what? Function. So when you check these two things here, you can see that one is one-to-one and the other one is not one-to-one. So which one will be a one-to-one function? It's not always also that when you do a substitution of s inside of a function, then you get 1 result to be 2. It can be also that you do a substitution of y inside of a function of x, then you get s results to be what? 2. So here we are going to consider the x-axis, the one where the graph, let's say this graph is g of s, this graph is f of s. If this graph, or if any of the graph cuts one axis of the s, then we call it a one-to-one function. But if it cuts 2, we will say it is what? Not one-to-one function. So looking at it carefully, let's say this is A, this is B. I'm sure you can bear with me that this one is not what? One-to-one function, but this is what? One-to-one function, because it's cutting only one axis and it's cutting what? 2 axes. So when it's happening like that, then we say this will have an inverse and this will not have an what? Inverse. Interesting. Let's move on. You will have it. So for a one-to-one function, f of s, you can have an what? Inverse. Yes, that's what I was saying. You can have an inverse. Okay. What it does is that it undo a function. What an inverse function. Let's say anytime you write something like this, it's talking of what? Inverse what? Function. What an inverse function do is that it undo a function. For instance, we have a function here and we have the inverse here, right? Okay. So you can see that this and this will undo this. So it will be left with only the what? The argument inside, that is what? X. So what is that? Is that it undo what? A function. Alright. Now let's look at something here. We have the graph of f of s. So if the graph of f of s is like this, the inverse will also be like this. You see that? The inverse. Two important things that you should be able to know it before we get there. If a function is continuous, I hope you know a continuous function because we have done it. If a function is continuous on a certain domain, f inverse will also be continuous on a certain what? Domain. What we are saying that if f of s is continuous on a certain domain, then f inverse will be continuous because the thing is a reciprocal of it. So if you can, then I also can. I hope you are getting me. Alright. So now, so that is the range of what? F of s. So what inverse function do is that, what an inverse function do is that, you can see that here, this graph is cutting where? The y-axis. But when it comes to this side, it's cutting to what? The x-axis. So the inverse is like a reciprocal. That's how it is. 2. differentiable, then take note of the second one carefully. If f of s is differentiable, then f inverse is also what? Differentiable. It's true. And you know that for a function to be differentiable, it has to be what? Continuous. And we are saying that if the function is continuous, then the f inverse will be what? Continuous. So if a function f of s is differentiable, then f inverse is also what? Differentiable. Thus, when we take the differential of f inverse, we are going to get 1 over the undo what? Function. And you know that is the same as 1 over what? X from our idea here. Alright, so we will continue. Wait a minute. Okay, so now we are not yet done, but we are now going to see how to evaluate inverse what? Trigonometry. Because if you know how to evaluate inverse trigonometry, when we get to the differentiation part, everything will be what? Easy for you. So let's go. Alright, so now the first thing is that 1. Let's say you have sine inverse of 1 over 2. You want to take the inverse of it, then this is how it's going to be. You will multiply both sides by what? Sine. Because what we are saying is that what a function do to an inverse is that it undo it. I always clear. Alright. So multiply both sides by what? Sine. Then you multiply this side too by what? So here is sine inverse of 1 over 2. So here is going to be sine y is equal to, and this will undo this. So it will be left with only the argument, and the argument is what? 1 over 2. Alright, so this is what we want you to know. Let's continue with it. Alright, so let's look at, if you have something like this, how will you evaluate it? How will you evaluate it? So watch, don't worry. It's just simple. It's just simple. So now, what you can do is that you are going to set the inside here. You see where the inverse is. So let theta be equal to cos inverse of 1 over 2. Now multiply both sides by what? Cos inverse. So when you multiply both sides by cos inverse, you are going to get cos theta is equal to, and it will undo this, so cos inverse of 1 over 2. So cos theta is going to be equal to half, right? Then, if you want to find theta, what will you do? You take cos inverse of this, so you are going to get theta is equal to pi over 3. Pi over 3. Alright, so that's what you're going to get for theta. Now we have set the inside here to be equal to theta, and the results we are getting for theta is this. Then we can say that tan will be equal, it will be tan of what? Theta. Because we have set the inside here to be this. So now if this theta is pi on 3, then here to be what? Pi on 3. And the result is going to be root 3. How you can see it? Wow. This is very nice. It's very nice. Alright. Let's see 1 or 2. Do something like, now take sine of both sides, and you're going to get sine theta to be equal to 1 over 3, because it will undo it. Alright. Now we know that sine is equal to, that's why we have so ka toi, right? So sine is opposite over what? Hypotenuse. So opposite over hypotenuse means that s is equal to what? Opposite over hypotenuse. That means that, y is equal to 1 and r is equal to what? 3. So we can solve this question by drawing our like this. So the theta is going to be here, and the y is going to be here, and the r is going to be here. So how will you get the adjacent? That is 1 square plus x square is equal to 3 square. A square plus this square is equal to what? This square. So x square is going to be equal to 3 square minus what? 1 square. And that's going to give you 2 roots. So x is going to give you 2 roots what? 2. So after getting here, 2 root 2, then you can see that if you have sine theta, if sine theta is 1/3, then cos is going to be cos what? Theta, right? So we have used the idea here to get this. So now that we have our right angle triangle, we can come up with any of the trigonometric functions. So now, if you want cos theta, we know cos theta is what? The reciprocal of what? Tan. If cos is a reciprocal of tan, and tan is opposite over adjacent, then cos will be adjacent over what? Hypotenuse. So this is going to be 2 root 2 over the opposite, which is what? 1. Therefore, our result is going to be 2 root what? 2. So we can say that cos sine inverse of 1/3 is going to be 2 root 2. Please, you have to understand this well, because this is what we are going to use when we are taking the differentiation of trigonometric functions. So don't forget it. Don't forget it. We have this, so we can set theta to be equal to the inside here, and the inside can be written in this form, and we know that this one is like so casual, so opposite over what? Hypotenuse. So when you represent the inside of this representation on the right angle triangle, then we can find the unknown part. After getting the unknown part, then any of the trigonometric functions you have, you can be able to get it, because now the inside here is theta. Alright, so see you for the next video.